Welcome to the session. In our today's session, we'll start with performance tuning in Oracle. So whenever we are using Oracle database or any other databases, if you are handling with huge volume of data, so definitely performance tuning is the very important one. So even if you are a ETL developer, the same performance tuning, you might be doing it in the Informatica Power Center or any other tools. Okay, if you go to any databases like Oracle, SQL Server, DB2 or Teradata or any databases, in real-time projects, definitely will be handling huge volume of data. So if you are handling huge volume of data, then performance tuning will be a very important one. Okay, mostly like if you are in ETL environment, then mostly like fact tables. So in terms of PB, it will have the data. Yes, definitely it will have the terabytes of data. So definitely we need to do a performance tuning. The most important, the most widely used performance tuning is the partitioning one. So we do have different methods of performance tuning. So that we will see one by one. So first of all, whenever we are doing the performance tuning, so first we have to go for explain plan. So you are running big queries, okay, SQL queries, you are running that. And definitely we need to check how the SQL query is running. So explain plan. So you have to run an explain plan. So first you can run the explain plan and it will tell you how the query is running. Then based on that, how much cost it is taking. So all this it will tell you. Okay, cost, CPU usage, and everything it will tell you. So by using that explain plan, you can do the performance tuning. Okay, whether it is going for full table scan or it is going for any other scan types. So based on that, you have to decide. So this is the one method we can go for. So explain plan. Then you can go for something like collect stats. You can put collect stats. So if it is very big table, you can do the collect stats. So in order to do the collect statistics, so that means it is a metadata table. Whenever it has the huge volume of data, so everything, if I want to go for statistics update, then Oracle will do the collect stats. So collect stats is mainly used to see the performance. Okay, how the not performance, it is used to improve the performance. Okay, one of the method and the collect stats. Okay, so then you will do the hints you will use. I will tell you what is that hints. So we'll have some parallel hints, all this. Then the optimizer. Okay, so you'll be using that optimizer. Optimizer is nothing but the optimizer knows it how to execute this particular queries. Okay, say for an example, you are moving from one location to another location. Very first time you are moving, so that time you will be plan. You will put the plan, right. Okay, how can I go from this particular location to this particular location? So you'll put execution plan. So next time, if you are running the same query, so it will go and check the optimizer execution plan, and then it will execute. So that's what it will go for. Execute the optimizer one, and then you can use the partitioning. The partition is very important one. Okay, we will see one by one. So partition here we cannot run it. So why? Because most of the performance tuning method. So we will not face any issues here. That's one thing. And also this partitioning, we can do it in the in enterprise edition only. So not with express edition. So in express edition, so in XE, we will not have it. So you have a real-time system, then you can run this. If you have any Oracle database development environment, you can create the partitioning and then you can check how it is running. Okay, even standard edition also, you will not see the partitioning. Okay, so enterprise edition, yes, definitely we'll see. If you get the chance to install enterprise edition, then you can work on this partitioning. Okay, but I will explain. So what are the things we have to consider while doing the performance tuning in real-time project? So whenever you are working on any real-time project, right? So directly don't apply select star from the table name. Okay, so don't use select star from any table name. So like this, don't use that. So why? Because this table contains huge volume of data. Okay, so don't use it. So first of all, describe the table. Okay, so describe the table and check. So what is the volume of the table, and you volume of the table, describe table you cannot find, but you can find whether the table has partition. If it is a fact table, right? Yes, you'll be finding the partition column. So you have to use in the where clause, and don't use star here. So always use whatever the columns you want. So even if you has multiple columns in the table, so use only that particular columns alone. So whatever the column you need, so that particular column alone you use. Don't use select star from the table name. And also, for an example, in real-time project, even if you are using any data warehousing tables, so don't use that select star from the table name. Don't use this select star from. Instead of that, use that table. Okay, if you want to check some few data in this particular table, then use, if it is Teradata, then use something like sample 5 or something. If it is any other databases, you can use, if it is Oracle database, use row num. So row num less than or equal to 5. So it will select 5 records only. So where row num equal to less than or equal to 5. So even if the table contains millions of data, it will select only 5 records, right? So you can check it how the data is. And also don't use star, and don't use all the columns names also. Whatever the column names needed, so that particular column alone use it. Okay. And if it is any other, for an example, AWS Redshift you are using, use that limit keyword. Okay, limit 5. So simply don't use where. So limit 5. Just it will select 5 records. In that way, you can select. Okay. So I have given one document here just to go through that. This is a generalized performance tuning methods. So whenever you are going with and cost effective methods, go for that cost effective method. And also the performance tuning is always is happening. Okay, it is not. So you have tuned today, but after some time, no need to do that. It doesn't mean that. Okay. So performance tuning is always we have to do. So whenever the data volume is growing up, the real-time project, yeah, definitely will be doing that performance tuning. So always minimize the amount of data. Okay, so amount of data that must be scanned. So don't go for full table scan always. So whatever the data you want to select, use filter class and filter out that particular record alone. Use some ranges like a where class. You can apply date range created by this particular time period that will reduce the number of record scanning. Okay. So that's what you have to use, and add more indexes on the table. So indexes on the table, but if you are going for frequently insert and update on the tables, don't use indexes. Okay, if you are frequently inserting or updating on the table, don't use indexes. So whatever the select statement you are going to do on the tables, so something like that, then you can use indexes. So do not include star in the select statement. Always use the column names. So that's why in Informatica or IACS or any ETL tool, we are going to use it. So automatically it will select the column names. Okay. And also don't use unnecessary columns. If you're selecting unnecessary columns, then it will create, even if it is Informatica Power Center, if you're going to use lookup catch and everything, if you're using select statement, it will create a lot of catching, right? So don't use that. And whatever the record data, that alone you can use it. So even in the database, use filter. And these are all the small things you have to consider. And whenever you are going for join, so use appropriate join conditions. So don't go for any Cartesian product. Okay. So instead of in keyword, you can go for exist keyword that will perform very fastly. So see here, do not use indexes to the tables that undergo more update or insert. See, if you are going for more update or insert or bulk update, don't use indexes first. So you drop the index, do the bulk insert or update, and after that you create it. Okay, that's what we will do. And use some temporary tables. Say for an example, you are building lot of in the joins. In the joins query, you are using some 10 to 15 tables, and tables you are using. So don't use all the 10 tables in the joins. So it will take lot of memory. So if it is a huge table, don't use that. So instead, create some temp tables. So create some temp tables and use the keyword called with. So by using that, you can able to create easily. You can use the query will perform. Okay, for an example, 2 to 3 tables you are combining and then creating the temp tables, loading the data, and then if you are joining it, it will be very easy. So even if you are going to deploy any code, right? Normally we will do temp table creation and then the same. Simply they are using select start from the table name. Select statement. You are using some reports. So in the report queries, if you are going to check in the above queries, you can easily find out they should have created some temp tables. So intermediately they will create some tables, and then from the tables you can do the joins if you are going for more number of tables. So these are all the some basic method to improve the performance. In addition to this, we can go for some other performance tuning method. Okay, so DBS also they will do performance tuning. So they will increase the caching. Okay, definitely infrastructure also it's one of the main thing for the infrastructure. So they will improve the caching size, the performance improvement. So all the caching size they will improve, and the table space they will improve, and they will go for more spaces on the database side to improve the performance. That they will do it on infrastructure side. So that means DBA they will take it. But ourselves as the developer, the SQL query developer, so we have to consider few things. So what is that? So first of all, whatever the query is running, just to go for explain plan. So explain plan for this particular table. So whenever you are doing explain plan, so it will give you what is the join method is performing. So some different join methods are there. I will tell you what are the different three join methods are there. So that it will tell you. So what is the join method it is using, and the access method for each table, how it is accessing the tables, and the different operations. So whether it is going for sorting algorithm, aggregation, filter, so all this it will go for select statement. So all this it will show you. That's what explain plan will give you. So join method, we have three different join methods are there. So I will explain that. So first join method is a nested join, nested loop join. So what is that nested loop join, right? So nested loop join means if the two tables are small table, okay, so whatever the query you are going to do, so if you are going for explain plan, so how the Oracle will do that? So we'll create nested loop join, then it will loop each and every record, compare with the other tables, and then it will give you the result. Patch join is the fastest join. It will do one table in the hash memory, okay, in the cache memory, other table, it will keep it in the outside. Then it will compare with each and every record. It will do the joins. Sorting means if you're going for two tables join, so one table will take it to the caching and then it will sort the data. So based on that, it will key column, it will join it and then it will produce a result. Okay. These are all the three join method it will do. Are we going to do? No, we are not going to do. So database will do it. We may not know what is the operation it is doing, but database will do. So if you are going for any explain plan, so these are all the access method you will be seeing that. The one thing is first one is full table scan. So normally we'll call it as FTS. That means the table is going for if you are running any select statement, so database is going to check all the data one by one. So that's why you can go for the full table scan. Table access by row ID. So each row ID it will select, it will store, and then row ID it's going for. So if you are creating a primary key or unique key, then it will go for unique key index. So unique index it will go for. Range index means a range of values. If you're selecting where class, some range of values. Okay, this value to this value. If that column has been indexed, then it will go for range scan. And index skip, so not between or not equal to, if you're going for indexed column, then it will go for a skip and full index. So all the data it will go for. And these are all the access method, different access method I will show you. Then you'll get a clear idea. I'm going to create one table here. Create table name, employees. Select star from. This way I just created one table. Okay, employees 2. If you check this particular table, it doesn't have any indexes. Okay, you know all indexes, right? So select star from all underscore indexes where owner equal to HR. Just I'm selecting. So these are all the tables it's showing. Then table name equal to, and table name equal to, I'm going for employees 2. So it doesn't have any indexes. So if you describe the table, describe employees 2, then you can find the column names, right? So these are all the column names you are seeing that. Okay. So how the indexes will work? Say for an example, I'm running one query. Select star from table name employees, where class, where salary, I'm going to use greater than 8,000. I'm just using this query. It is selecting 32 records and then it's showing. But how this query is running, I want to know. How the Oracle is going to check. See, if you have how many records there in the table, the employees 2. You see this 106 records it has. How the Oracle will run? Whether it will go and check directly 8,000 who are all getting 8,000, or it will go and compare each and every record. So it will go and it will compare each and every record, right? That is our full table scan. So if you want to check how this query is running, then you have to run explain plan. Okay. So run explain plan for, so always use the select statement. Okay. So explain plan for select statement. You can run this way. So if you are running this way, then it will show you explained. So after that, you can use, okay, this has been explained and then it will store in the one particular package. So that package is, you can select in this way. Select star from, so you can use, I will give you this particular statement. So select star from table of dbms underscore explain dot display. So if you are going to run this, how this query is running. See here. So very first query is running. Select statement. And the second one, it is going for full table scan. So full table access, employees table. You are seeing the cardinality, it is taking 104 records. Okay, so this particular cardinality means it is taking 104 records, checking how many records it's going for, 104 records, and the cost is 3 here. Okay, 3, this is what it is showing. You are using some filter condition, filter to 8,000. Okay, so you can run this way. The other way is in SQL developer, you can use simply, don't use explain plan, just to select this query. You can see here explain plan for, right? So you can run this. It will give you, okay, full table scan. Cardinality it is going for 104 record. That means these many records it's checking. And cost is 3, CPU cost. And this is what it is using. Then the database version and all this it is showing hints. Okay, how this it is using. So this is what it is running. The query is running. And you can see, or you can select this particular statement. You can press F10. So press F10 in your system, then it will give you the same result. Okay. But if you are running, this is the best method. Explain plan for, just to explain it. You can see the hash value here for this particular explain plan. Okay. So it is going for full table scan. That means each and every record it's comparing and then it is giving you the result. Okay. But I'm going to create an index on this particular table, on the particular column. So whatever the column you are frequently querying a column, so that column you do the indexing, the where class. So I'm going to create an index. So how will you create an index? On salary column, we can go for B tree index, right? So create index, index name, IDX, EMP underscore salary underscore IDX on, what is the table? Employees table, salary. You are going for the column name salary. This column I'm going to create it, but I will take this particular plan. See, this plan is for CPU cost is 3, employee 2 only I have to do. So why? Because employee 1 already indexed. So employees 2, it is going for 103 records. So here also cost is 3. So it doesn't have any indexes, all this. So I'm just creating index on this particular table. So index has been created. So now I will go and execute this particular statement. Okay. Explained. And I'm checking the explain plan. Okay. Still it is going for the same cost. Session. We will terminate the session. So you explain plan for select star from. So again, it is going for full table scan. That means it is comparing with each and every record. This particular index is not correct. The column you are selecting, right? It is not going for the full table scan. It is going for the index range scan. So range of values, you are selecting greater than 8,000, right? So that means the cost is very less here. So 0, 1, 2, select statement. So how to interpret this explain plan, I will explain later. But this is what it is going for the indexing. But previously it was selecting 104 records, right? So now the cardinality is 11 records only. Okay, it's checking these many records only. So that is what the cost has been reduced here. Okay, if you are going for huge volume of data, definitely you can find this cost has been reduced very less. It's going for index range scan, right? So how to interpret this particular explain plan? So normally you have to go this way. First you take the topmost one. So first you take 1. So first one is 0. So 0 here. Then it is going for the table access by index row ID. That is 1. So this is 0. Then this is 1 here. There is no parallel. Sorry, there is no parallel one, right? So you can use 1 here. Simply you can use 1. So this step is executing. Then it is going for the next one, next step. So if you see this index range scan, so that is 2. So if you have to write this way, but still has all this hierarchy here. See here, there is no in between step here. So that's why I have written this way. So while you are interpreting how the Oracle will run. So from the bottom, it will run. From the bottom left-hand side, it will run. So this way, this is the way it will run. So there is no leaf, there is no branch here. So it will go from the below bottom on. First, it will execute the second step. So index range scan, it will execute this particular index name, and then the cost is 1. Then only it will go for the table access by index row ID. Then it will run the select statement. On top of this, only 11 record it is taking. Row ID it is taking. That means select star from this record. So 32 records are there, but the indexing it is making only 11. So it might be having some duplicate record. So distinct salary, if I'm going to take count of distinct salary. So I'm going to select. So 18 we have, but it is making the explain plan. Sorry, 11 records it's making. And this is these many bytes. See, whatever it is taking the row ID, a row ID given to the select statement, and then it is selecting. So this is what you have to interpret. And you can see this is going for the explain plan, right? So this way. So if you want to go for a complex one, so what I'm going to do, select start from departments 2. This is another table I have. Okay, departments 2. So what I'm going to do now, the employees table, departments table, I'm going to join it. Employees and departments, I'm doing the join. Okay. So I'm just running that, it will give you the data. So here the department ID is the joining column. So I'm going for explain plan. So before that, I will clear this particular session. Explain plan for employees to departments to. I'm not changing any data in the employees table. Just I want to do the employees to table. Okay. So I'm going to run this explain plan. It has been explained. So now if you go and check, you can find. So how this is running. So employees to table. If you see this, now this is going for nested loops. Okay, nested loops cost. You can see here how it is running. So very first time when we are going this 0, 1, 2 and 3 is parallel execution. You can see here parallel execution, right? So that means 0, 1, 0, 1, then 2 and 3 is parallel. So how Oracle will run, right? So this way it will run. This is second step. This is third step. While moving from top to bottom, you have to take but left hand side from left hand side. Okay. So first it will run second step. What is the second step? Table access full. So it will take all the data from a departments table. Okay. It is taking all the data from departments table and table access full, all the data from employees table. Then it is going for the nested loop. So first step. So it is taking all the data here in the cache memory. It is taking all the data here. And then these two, it is going for the nested loops. Okay, based on the joining column, nested loops. Nested loop means small tables, it will go for the nested loops. So I will give you one document here. Go through this particular document, explain plan. You will find a different concept here. So cardinality is nothing but number of records in the queries. And we'll have the join method. So if you see the join method, so what is the joining? It is running. Okay, hash join. So a lot of hash. This is the fastest method. The join method. You can see hash join means hash joins are used for joining a large data set. See, whenever your query is running, so if it is going for the hash join, it will go for large data set. First, if two tables are large data set, then it will go for hash join. What is meant by hash join? The optimizer. Optimizer means Oracle will run that query, right? That is the optimizer. Uses the smaller of the two tables. So we are running employees table and departments table. Department is small table, and normally that is what it will normally, even in Informatica also, Informatica it will run in this way only, right? Smaller table, it will go into the cache memory. That's what master table will create a small table, right? Same way here also. Smaller of the two tables are data sources to build hash table based on the join key in the memory. Then scans the large table and performs this hash algorithm and it will produce the result. Got it? If you have two tables, so if you are having a big tables here, big tables, and you have the small tables, this small tables will be moved to the cache memory. So cache memory, then each record from here, it will be compared with all other records in the large tables. It will produce a result. This is the hash algorithm. Nested loop means both are small tables. Okay, so nested loop means useful when small subset of data are being joined if there is a efficiency way of accessing the table. So for every row in the first table will be compared with second row and then it will produce the result of the for loops. Each and every record. That's what it will go for the nested loops. So it is taking data from these two tables and it is doing the nested loops. Each and every record has been compared and then it is producing the result. Select statement. Okay. So what we can, how can we implement some tuning method for this particular query? So different method is there. One of the method is indexing, right? You can create an index. So on that, see, we have the nested loops, right? After that, sort and merge joins. So whenever you are using any greater than, less than, greater than or equal to, less than or equal to, any conditions, if you are using that, so first it will go for sorting algorithm, then it will merge the data. So that's what it will go for, sort and merge joins. So normally this is what it will do. See here, sort join first it will use, and then result will be merged. See, whenever this is totally 7 steps are there. So you have to go from, so first one, okay, one. Then you have to see very the parallel way. Do we have any steps? No. 1, 2, 3. So 3 also there is no step. 4. Yes. You see this 3, third step and fifth steps are common. Both are in same step play, right? So these two in branch, and after that this one in same branch, and inside the partition range all going for the full table scan. So this one it is going for the full table scan. That's what you have to interpret. One by one, we can check how it is producing the result. Okay, but we are not going to do anything. So Oracle will take. You see this, I'm going to create an index on the department ID column. So normally you can create bitmap index, but we do not have access here. I will create normal index here. So create index name, EMP underscore DEPT underscore IDX on employees 2 table, the department ID column. Same way, departments 2 table, I'm going to create one more indexing. Okay. Departments 2, department ID. Just I have created in one more index on this. So now I'm going for the explain plan. So before that, we have seen different way, right? Now we will see the different way. So I will clear that. I will run one more time explain plan. So this time it will not go for full table scan. So two table, and I'm just running for explain plan. It has been explained. So now I will run this query. See, previously it was taking full table scan, right? So now it is going for, see, normally no need to clear that session, but why I'm clearing it? It is giving you the previous explain plan result. That's why I'm just clearing. It's not automatically clear in my system. Okay. See here, it is going for this way. So 6 steps are there totally. So how can we interpret first? Say 2 tables, employees to this table. So first we will go for 0, select statement. Okay. On the top we have 0. So 0 here. What is this? So this is the top select statement on the top. Then, so how to interpret? What is the meaning of this one? Then it is going for the nested loops. Do we have any branch on this? No. Nested loops 1. So you can go for nested loops 1. This step. Then it is going for second nested loops. In the second and the fifth step are parallel, right? So you can see here, both are in the same branch. So second step and step, both are in parallel way. It's running. It is going for this one. Then you have to take these two, 3 and 4. So 3 and 4 from second step, right? So 3 and 4 is running in parallel. So now tell me which step will run first. So which step will run first? Can you tell me now? So always you have to go from bottom left to top. Bottom left to top. Okay, so always you have to go this way. So first you have to go with third step. Third step only it will run first. So which table it will take first? It will take departments table full table scan. So Oracle will very first time while running this particular query, how it will run? So departments to table, it will go for full table scan. So that's the third step. Then it will take the fourth step. Fourth step is it is going for the index range scan. Index range scan on employees department index. So employees department index means, so it is taking this table and this table, right? So employees department index. So in that way, first it is running third, then fourth.
How you are able to identify it that is running parallelly? I mean, you're just making like this step is running, so it's parallelly, but I'm getting it out over there.
So if you see this, first it will run the first zeroth step, okay? That is select statement. So do we have any parallel step here? No, right? There is no parallel step. Then it will run this one. Right? First step. So do we have any step here? Any parallel step for this?
No.
No, right? Then the step. Do we have any parallel step for this?
Yes.
Second and 5 is parallel, right?
Yes.
So it will run. So that's why I have put 2 and 5 in parallel. Then third and fourth. So if you take third and fourth, okay. See, sorry, 3 and 4. So 3 and 4 is parallel. First it will run the zero step, 0 here. Then it is going for the 1. 1 is not in the same line, right? Is it in the same line, nested loops? No, that's why I'm making like branch. Next line. Then nested loops. Then 1. So do we have any parallel line for this one? So this is what it will run. So from first you have to go. So from here it will run. So whenever you are going to interpret, you have to interpret from the bottom left to the top. Okay, to the top you have to go for. So you have to take third step and fourth step, and it has to take it from the second step. So these two second step it will run. First it will take the departments table, departments to table, and then it will go for the nested loop on the employees to table with the range of indexing. So index range scan. Then the resultant will go to the first step, nested loop on the second step and fifth step. So what is that second step? So the resultant of these two, right, will be taken. And the fifth step is table access by index row ID. That means it employees to table. It will go for again the index row ID, and then it will go for the select statement the top. So that's what it will interpret, and it will produce a result. So when we are not going to do anything, as a developer, we are not going to do. But since you have created the index, you can check whether it has been improved the performance or not. Okay. See here, it is showing that where it is starting from. It is starting from index on the employees department IDX. So what is that employee department and IDX? So this index, the employees to table, right? So employees to table based on the department ID, it will create a range scan based on the row ID. Row ID means each and every record it will go for the row ID. So how it is making the row number, the same way row ID will be there. So based on the row ID, it will go and check. So this is what it will go for the explain plan. If you are creating indexing, so you can go for any other complex SQL also. Same way you have to interpret any complex SQL. If you see this table, I'm going for the explain plan. So normally in my system, it is not clearing the explain plan. So that's why I'm doing that explain plan clear. Just to run explain plan for 3 tables this time. So all the 3 tables, but I think on this table, there is no indexing. So how it is running, how this step you have to run. So first you take 0 step. So even if you are not clear how it is running, check like this straight line. Do we have any parallel line for 0? No, right? So that means 0 is running first. 0 step. This one only will run last. Okay. You have to go from bottom. So then you have to go for first step. First step you take. Do we have any parallel? No, there is no parallel, right? So you have to run. You have to put first here. From the first step, you can see 2 and 6 are straight line, right? 2 and 6 are running in parallel. So that means you have to take and 6, 2 and 6. Then you have to take these two, 3 and 4. So 3 and 4 from where you have to draw? From second, right? See, these two is running parallelly from the step from second. So this is third step. This is fourth step. These two are parallel. Okay. And then you have from fourth step to fifth step. From fourth step, you have the fifth. So first you have to run. First you have to take the fifth step. Clear on this? Now you are clear. So first it will run. Fifth step only it will run. So department location index. So that's going for the department's locations index range scan it is running. Okay, after that, you have to take the third table. The third step, table accessible. Yes, locations table it is taking. And fourth one is departments table it is taking both. And it is going for the nested loop. Second step, nested loop. With this resultant, the sixth step is employees table. It's taking the employees table. Whatever the resultant we are getting that, the employees table, then it is going for the first step, nested loops. These two is comparing these small tables, right? Then both are like, see, first it is taking locations and departments only based on the index. Some index is created. Some department, I think department ID we have created. Based on the index, it is going for. What is nested loop? Nested loop joins are useful when small subset of data are being joined. So are we going to do nested loops? No, we are not going to do nested loops. Who will do? Oracle will do it. If small table, then it will go for nested loops. If it is a big table, then it will go for hash join. Okay, large data set, it will go for hash join. When it will go for sort and merge join, whenever you have any greater than less than symbol. Okay, and then it will go for sort and merge join. It will go for. You can test it. You can use something like some let outer, right outer, all this join. Then you can see this merge join. Partition means it is making all the partition product. So when you have time just to go through this particular document, you will get to know all this clearly. See cost, what is the cost? Oracle Optimizer is a cost-based optimizer. So whenever from Oracle 7, 7th version, before that we have the rule-based optimizer. After that, we have the cost-based optimizer from Oracle 7. The execution plan. Okay, so how, see if you are going from India to USA. So very first time you are going from India to USA. Okay, very first time you are going. So what will you do normally? Okay, so what will you do? So that's nothing. The star is nothing but it's going for the indexing. So that's a leaf nodes, last node. So you are going from India to USA. So you assume that very first time you are going with. So direct, there is no direct from India also you are going from some locations. So you are going from Hyderabad or Chennai. This particular location. You'll be going for some transition, right? So you can go for Chennai to some locations, Mumbai or Delhi, then Delhi to some other locations. Then, so you'll be going with some Gulf countries and then you are going to USA, right? So very first time you are moving from this way. So you will be planning all this. Okay, how can I go to this particular one? Okay, second time you are moving. Second time you are moving. So this is some other way transit you are making, and then you are going with. Third time you are going. So if you are running the same queries again and again, Oracle knows it, how to execute it. It will store the optimizer will store the execution plan. So what is the easiest method to execute, right? So if you are running from India to USA many times, then you will know which flight is very cheapest way and which is the very short timing. Okay, it will take, right? So that you may know. So why? Because you are getting multiple times you are running, right? That's the way. So that's what it is making the cost-based optimizer. I will tell you after what is the role of optimizer. The optimizer selects the execution plan with the lowest cost. Okay, so which is the lowest cost? Where the cost represents the estimated resource usage for that plan. The lower the cost, the more efficient, right? So input, output, ICPU, network resources, everything will be used. So that's what the lowest plan. Okay, got it? So you have to cardinality if you're seeing estimate of the number of rows coming out of each operations. So that is the one thing. And the access method is the access, the different methods we have, right? So whether it is going for full table scan, index access, all this you are going with. And join method is, this join method is using, join type is, what is the join type is using. This join type we will mention in the query. And partitioning, I will tell you, okay? So parallel execution, all this you are able to see. Okay, so number of records. So all this, it has been mentioned here. So I will give you this particular document. You go through this document, you will get to know clearly how to interpret all this. So you have to run always explain plan, check whether how the explain plan is running. From that, you have to identify. So whether it is going for full table scan. See, even it is going for the full table scan, right? So you have to optimize that. Don't go for full table scan. Still, it is going for the full table scan. So create some indexing on the department ID column, then go for it, or create the partitioning. So if you are creating the partitioning here, department ID and location ID, indexing all this, it will not go for this much full table scan. So first six steps, it is what the prediction. Okay, you ask star here, right? Star here is nothing but this is what it will display here. So what is that? So access d dot location ID equal to l dot location ID. This is the least step, right? Then it will go for department ID equal to department ID. Filter access it is doing. Star is meaning has been explained in the below. So what is operations ID? So ID number, operations, name of the operations, how many rows is returning, cardinality and cost, how much time it is taking. So all this you can able to find. So this is nothing but your the explain plan. You can select from this table also. Select star from plan table. Okay, explain plan for you have to put always select statement. How the select statement is running. So do the collect stats and then check how the explain plan is working. Then you can find, okay, it's running fastly. Then you can use hints, optimizer, all this. See, optimizer, we have two optimizer. One is rule-based optimizer, another one is cost-based optimizer. Nowadays, we are using only cost-based optimizer. It's nothing but we are the user. Okay, you assume that we are the user. We are running SQL query. We are running just one SQL query. Assume that this is the first one. You are just executing one SQL statement. Select star, any execute joins or something you are executing. First step is parser. So what is parser will do? This select statement is our understanding, is for our understanding. But how in computer will execute this? Computer will go for parsing engine, will convert this one into zeros and ones, machine executable language. So that only it will convert. Okay. Then optimizer will check whether this query has been, whether this query has the execution plan, previously execution plan or not. It will check. So it will go for cost-based optimization. That means it will check in the dictionary. Okay. So if you are running any query, how to execute that? Whether we have? Yes. See, you are running from, you are moving from India to USA. Very first time, do you have any dictionary, any reference or something? No, you will not have it. Very first time you have to go. After that, you will get some experiences, right? So that experiences is nothing but, see, in our memory, we will store it. In our brain, we will store it. But how a computer will store? Computer will store it in the dictionary tables as a statistics. Then the optimizer will check whether it has been executed already. Cost-based optimizer will check this execution plan already exists or not. It will give you the query plan to the row source generator. Then it will execute the execution. SQL execution will be happening. It will give you the result. So normally this is what it will execute. The optimizer will execute each and every statement in that way only. So from Oracle 7, you have to use the Oracle will use cost-based optimizer only, not rule-based optimizer. So this way it will not use. It will go for cost-based optimizer. It's nothing but already execution plan will be stored. Okay, how many tables are there? 2 to 3 tables. So you are running same reporting queries multiple times. Very first time only. Very first time if you are running a report query, then it will take much time. Then it will go on creates. Say for an example in the mobile also, you'll be hashing some. You'll be seeing some hash file, right? Hash file. So what is that file? See, whenever you are accessing that particular folder or something very first time, then it will make some indexing. So with that, it will next time it will give you the each and every result very quickly, right? As any picture or anything. The same way here also it will be doing. So that's what the optimizer hints will do. See, you can use hints to specify the following. See, normally you'll be seeing this kind of hints in the real-time project slash something like 32-bit 64 all rows something you are using. So it is informing. So lot of hints is available cost-based approach. So you can inform them. Okay, inform Oracle that so how to execute this particular query. Then based on that, it will execute. So normally we used to put something like *64. That means you are running parallelism. Parallelly, you are running parallel hints. This is called parallel hints. You are running the same query in a parallel way. Instead of running this entire query as in a single pipeline, you can go for parallel pipeline. Then you can use execute this particular query very quickly. So just you have to mention, but not all the queries. If you're using all the queries, right, then it will take a lot of time. See this parallel hints. See parallel HR 5 parallelism you are running. Then it will split this table into 5 parallel, full table into 5 parallel. Then it will make very quickly. So this is a first 10 rows only. Selecting. So use exist keyword instead of in keyword. That's a normal we will use. Okay, so these are all the methods to use some performance tuning, but still we have some methods. The best method is partitioning. Most widely used method is partitioning. In real-time project, whenever you are going for any fact tables, lot of fact tables will be there, right? In the environments. So definitely you can go and check some describe table you can put, and you can see partitioning will be there in the table. We will continue with partitioning. See, partitioning only, it's very, very important. In the real-time project, if you're going for any tables, so definitely it will be partitioned. So what is partitioning? See, if you're having big tables, so you're having big tables, huge volume of tables, then if you're using select statement, select star from the table name, if you're not using any partitioning, even you can use indexing, that's fine, but you are not using any partitioning, it will go and check all the record one by one, all the record. But we can create a partitioning. So how? See, you are going to split this table into multiple partitions. You are going to one mobile shop. You assume that one mobile shop you are going with. Mobile shop you are going. In front of you, all the mobiles they are placing here. You are asking some particular brand, some Samsung brand or a so iMobile you are asking some brand you are asking, okay, or Redmi or something you are asking. If all the mobiles are kept in this way, you are asking particular mobile, the showroom the person needs to check with all the mobiles, right? So one by one needs to check all this. Instead, he has partitioned. See, definitely it will be partitioned. All the stationery and everywhere it will be partitioned. You're asking some iPhone or something. Directly they will go to this particular rack. Even inside that, you'll be having a lot of partitions, correct? So you'll be having inside that also, you'll be having a partitions. Yes, you can go for indexing all this. So iPhone, what is the model you are asking? Okay, this model will be available here. This model, yes. You're going for some other brand, Samsung. Yes, you'll go for Samsung. Lot of models are there. Each model will go for one more partitions. So this is the way. If you have partitioned, are you going to check all other remaining partition? Are you going to check? No, you will not check it. So why? Because since you know this where class, I need something like that. If you are using where class, you are showing that, okay, I want this particular brand. If you are not telling this where class, so what this particular showroom person will do? They will go to one partition. They will ask. They will show you. Okay, you want these mobiles? You want these mobiles? You want these mobiles? You want these mobiles? Something like that, right? So they will ask some questions. Based on that, they will go for this way. So that's the same thing in the partitions also will happening. So partition is nothing but in an Oracle database, partitioning enables you to decompose very large tables and indexes into a smaller and more manageable pieces called partitions. Each partition is an independent object. That's the main important. Okay. So independent object. So each and every partitions will be treated as independent object with its own name. Say for an example, this name is table name space partition name. So in Oracle, we can say it's a partition P1. So to find information on the partition, you can query this, select star from all tab partitions in Oracle. Use this particular table, all tab partitions. So here we do not have that. We cannot create the partitions since it is not enterprise editions. So all tab partition is nothing but it's a metadata table. In this table, you can use where owner equal to HR and table name equal to this table name. You can find all the partitions. Okay. So what are the different partitions views are there? So normally when to partition a table? So when should I go for partition? Simply all the table can I go for partitions? No. If the table size is more than 2 GB. Okay. If the table size is more than 2 GB, then go for partitions. How do I know whether this table is more than 2 GB? We have metadata queries. So based on the database, you can find. See, if you're going for real-time project, most of the fact tables and real-time projects are in terms of terabytes. Do we need to do partitioning? Yes. Most of the dimension table will not have in the particular range. 2 GB, we will not have it. But most of the fact tables in real-time projects, in terms of TB, you will have all the data. So that we have to do. Tables which contains historical data. Yes, of course, the tables contains historical data. SCD type 2 tables, even dimension table also, if it has more historical data, so definitely will have more than 2 GB. So that particular table, you need to go for partitions. Okay. So you have to add it into the new partitions. Okay. So when contents of the table needs to be distributed in a different storage devices. So that's what this is one device. So the storage device also you can go with partition one is there in one particular device. Partition two on the same table is there in different devices. So that is also fine. But Oracle knows it where the data has been stored. When table performance is weak, then you can go for the partitions. Okay. So whenever you have the huge volume of tables, then go for partitions. See, normally in real-time project, so transaction tables, sales table, invoice table, orders table. So these tables will have any historical table, need to have a partitions. Two things you have to remember whenever you are going for a partitions. The first thing is partition key. Okay, which column I need to go and do the partitioning. Okay, which column I have to do the partitioning. See, if you have employees table, based on the table, you can select, okay, which column I can go for the partitioning. First one is partition key. Okay, which column you are going to create a partitions. Set of one or more columns. Can I create partitions on more columns? Yes, you can create. Set of one or more columns that determines the partitions in which each row in a partition table should go. Each row is ambiguously assigned to a single partitions. Yes. So it will go and each partitions. Okay, it will go on each partitions. Then we have the partitioning strategy. So this is the one. So you can go for single level partition or composite partitioning. What is single level partitioning? This is single level partitioning. Okay, this is single level partition. Composite means, so this is composite partitioning. Inside partition, you will be having another partitions. So that is composite partitions. Okay, these concepts are common between even you have the Hive tables, you'll be having buckets, right? Partitioning and bucketing. Same way here also. See, types of partitions in Oracle, we have 4 types of partitions. How many partitions are there in Oracle? 4 partitions are there. One is range partition, list partition, hash partition, composite partition. Composite partition means you can combine any of the partitions like range and list, list and hash, hash and range. So you can combine and then you can create a partitioning. So that is a composite partitioning. Okay, composite partitioning is the partitioning strategy. Range partition. See, range partition, it's similar to Informatica. So if you know the definite range, so you're going to use, say for an example, employees table. You have a salary range. Yes, you can create a salary range partitioning. One is range partitioning. What is the range partitioning? Range partitioning means you are using some definite range. Okay, 5,000 to 10,000. That is one range. 10,000 to 15,000 is another range. 5,000 I'm making. Okay, 15,000. So this is range. And if you go to fact tables, mostly in real-time project, most of the fact tables are range partition with a date column. So whenever you have a date column like created timestamp, updated timestamp, created month, updated month, something date range partition we have. So created at some month we will use. Each and every month we will put it in one partition. Or if you have more volume data, each and every date we will put it in one partition. So you have to mention that the interval is 1 day. So you have to mention interval. So what is that interval? So if you know the definite range, you can put range. You can define the partition 1, partition 2, partition 3. Then you have defined, okay, say for an example, today you know the range 0 to 5,000, one partition, P1, 5,000 to 10,000, P2, 10,000 to 15,000, P3. That is what you know as of now. But after that, you have to mention every 5,000 is the range. You have to mention interval 5,000. Then say up to P1, P2, P3, we have given the name, right? After that system itself, it will assign some name. Sys underscore, some name it will assign. I'm just mentioning that P4. So interval 5,000 range of values, then system will assign it some ranges. So this is what it will go for the types of partitions. You can see here, there are 3 different types. One is list partition, range partition, hash partitioning. So what is list partitioning? We have to define the list of values. You are mentioning P1. Okay, P1, you are mentioning that values, East sales regions. So that's you are mentioning that list of values. New York, Virginia, and Florida. These 2 you are mentioning in the partitioning one. So when to use this partitioning? While creating the table. Okay, so create table, you have to mention the partitioning. So like P2, if any values you are inserting, where central, where region equal to some data you are making this range, this value. So you are inserting. So insert into table name. You're inserting sales region equal to Texas. Where which partition it will go and store? This particular record will go and store in the third partition. Okay, if you are using any other regions, like you are using some New York regions, it will go to first. You are select star from the table name where some region equal to is sales regions. We are mentioning that. So Oracle will not go and search these two table, these two object, it will not go and search. It will go and search only this particular partitioning. So inside that also you can go for one more partition, that is range partition also you can go with. So that is composite partition. See range partition. So January and February always month you are going with. So that is one partition. March and April, May and June. So 2 months you are selecting. That's what you can restrict the data. So directly it will go to this particular partitions. Then hash. Hash means we are not going to define just column names. You will define it. Hash algorithm it will generate. You know the hash key, right? Some 32-bit hash key will generate. So based on that, it will go on to put it in one particular partitions. Which column we want to define the hash, that column. If the data is changing in that column, the partition will get changed. What is composite partitioning? You are going for composite partitioning here, range and list partitioning. The right hand side, if you see this, going with the range and composite partitioning, both you are using range partition and list partition. So that means this is the list partition. So within this list, it will select, okay, if I have any data for this particular range, if I have data based on the January and February, it will store here. That means narrowing down one more time, right? As I told, if I have the rack here, so you are going for iPhone only. Inside the iPhone, you are making more racks here. You are defining each model here. So in iPhone, you are asking some particular model. In iPhone also, I no need to check these models, right? These models, no need to check. You can directly go to this particular model. You can define. That's the way you can see here. So this is a list. And this way, we have the range. Okay, range. The range and list both. Then here we have range and hash both. So inside one range, so January and February, you have hash 1, hash 2, hash 3, hash 4 in that way. So take this particular table, sales table. Okay, if you see this sales table, you have some product IDs, customer ID, time ID. Some time the sales is happening. So you can see 98, 2000, 2001, 98, 99. All this data is happening. Some channel ID we have, some repeated values are there, channel ID, right? Repeated value. So you can go for. Then some promo ID. So if you see promo ID also, we have some duplicate record. So you can go for promo ID and list partition, right? And channel ID also list partitioning. And this time ID, you can go for range partitioning. Okay, you can put some ranges and quantity sold, amount sold and all. These are all the data will store. If you see here, I'm creating the range partitioning, time ID as the range. How can I create it? Normally you will create table name, all the column you will mention, close it. Normally this is what you will open and close it, right? We will put semicolon here. But instead of making the semicolon here, we'll make partition by range. So this is the keyword. Partition by range is the keyword. So which partition strategy you are going for and which is the partition key? See, this time ID is the partition key. So based on the time ID, range of values, it will create a partition. Okay, how many partition I'm creating? As of now, 4 partitions. What is that? So less than 1998, sorry, 1999. That means up to 1998, we're going for one partition. Then less than 2000. Less than 2000 is one partition. Less than 2001. So that means each year we are going for one partition, and other partitions, all the partitions we are going for maximum value. See, one disadvantage, this query. So what could be the disadvantage in this query? Sales 98. So you can see here all the 98 you are loading into one particular partitions. Whenever you are inserting the data, it will go to this partitions. Whenever you are inserting any data on the 1999, it will go for second partitions. 2000 will go for third partition. Any other date it will go for this partition. But one advantage here it is, so if you have more values for this particular, more than 2001, if you have any values, then all this will go to one particular partition. That is what we will call it as skewness, right? Skewness. So the table will be skewed. One partition will have more data. So we should not go for this one. So we will have one method called interval here. Okay. So what is interval? You have to mention the interval here. So how much is the interval? So interval is, so here it is a 10,000, not 1000. It's 10,000. See here, partition one will go to up to 10,000. It will go to partition. That means what is the partition key here? Which one is partition key? So partition key is salary here, right? So you can see the salary here. So what is the partition? How many number of partition we have created? 4 number of partition. But this partitioning is dynamic partition. Why? If in future, if you are getting any values, something like 60,000, okay, 60,000, 65,000 or anything, so automatically it will go to the particular partition. How? We are making this interval. So this keyword you have to use. Okay. So use this keyword to dynamically create the partitions. So who will create? Oracle will create. So make sure that you are using that keyword called interval. Okay. The other one is enable row movement. See, this is very, very important. So what is enable row movement? Whenever you are using any partitions, use this enable row movement at the end. So that means, so today you have some data. You have some data. So salary is less than $10,000. So 8,000 you are using. So which partition will be there? Very first time, it will be there in the E1 partition. Okay. But you are updating this particular record. Sometime later, this particular record you are updating. See, if you haven't enabled row movement, what will happen? If you are updating this particular salary from 8,000 to some 21,000, you are updating. You assume that that particular record you are getting updated. If you don't mention this enable row movement, still this particular record will be there in the P1. That means wrongly it is there in the P1 partition. Where it should be there? It should be available in P3, right? So P2 is 11,000 to 20,000. Up to here it will be. So 21,000 should be there here. So whenever you are updating any record, if it should move to the other partition, okay, then you have to mention enable row movement. Clear? See, you go and check in Oracle table. So these two should be there. Definitely these two should be there. See, first one is partition by which partition we are selecting. Partition by range. Yes, it is a range of values, right? Yes. Which column? Partition key. Then what is the interval we are using? Interval is 10,000. Enable row movement means whenever the dead card is DML operation, you are doing that, automatically it will be moved to the other partitions. Got it? So you want to select only P1 partition data, then you can select this way. Select star from the table name where, sorry, no need to use where class. Select star from the table name, partition P1. If you know the directly where how the data has been stored, you can select this way, partition P1. But if you are selecting, select star from the table name where salary less than 10,000, which partition it will go and check? 10,000. It will go and check in the P1 only. Whether it will go and do the all other partition? No, it will not go and check. So what is that interval? What is the enable row movement? So how to select partition key and partition strategy. Are you clear now? Okay, you can see here. See, you are doing the collect stats. You have to run this particular statement. If you want to run the collect stats on the employees table, okay, you have to run this particular statement. So execute. This is PLSQL statement. You are running that DBMS stats, gather table stats, schema name, table name. Just you run it in the real-time project also. See, before collect stats, it is showing that same table. You can see here P1, P2, P3, P4. 4 partitions we have. Last analyzed is null. Number of rows also each partition don't know. And blocks also don't know. And sample size also don't know. But high value is mentioning like here 1000. So 1000, 2000, 3000, 4000, 6000. See, these values are there. So can you identify what is this? How it is created? System underscore P7 741. See, we have created partition 1, partition 2, partition 3, and partition 4. But this partition, it's automatically created by the keyword called interval. If you haven't used keyword called interval, this record will not go to this partition. It will go to the P4 only. So remember this, that's what I have to mention here. And if you're refreshing the statistics, so from here you are seeing that, okay, last analyzed on this particular date. So number of blocks and total number, the blocks, the number of blocks and total number of blocks and sample size. So that means how many records are there in each particular blocks. And you are seeing the high value of the particular blocks. Okay, collect stats. So you can run the collect stats. The metadata tables will get collected. So this is what the collect stats you have to run. So whenever, why we are running the collect stats? After doing the DML operation on the table, DML operations on the table, if you do the collect stats, Oracle knows it where the data has been stored. So you remember in Informatica also, I have explained that. So we can do the collect stats on the source table. We can do the collect stats on the target table after inserting the record. Why we have to do the collect stats? So if you do the collect stats, the analysis will be done on the table. Got it? The analysis will be done on the table. Then Oracle will go and first see the statistics. It knows the values. If you're selecting some value, select start from, it will go and check the statistics. From here, it knows which partition the data has been present. From that partition, it will select the data. So this and all, you have to do that scheduling. You have to schedule it. Collect stats on the table. In the last statement, you will put some collect stats, any DML operations. Even in the real-time project, if it is Informatica, in Informatica Power Center, we will put this particular statement at the post SQL. So post SQL, if you put this right, after data getting loaded, it will do the collect stats on the particular table. Okay, so you can see here list partitioning. List partitioning, we are going with channel ID, some list of values, right? So 2 and 4 is one particular partitioning, 3 and 9 is the different partitioning, P2. Odd number, even number, something like that we are making. So 2 and 4 channel IDs are into one particular partitioning, and this one another partitioning. If you are getting any other values, so that means it will not go to any partition. Okay, it is go to default partition. Then if you have more values, then it will go for skewness. So don't get into this particular one. You put some interval. So interval of values so that it will go to. So, but you know, definite range here, definite list. If you know country ID, some list of values, then you can go for list partition. Hash partition means based on the product ID, you are selecting the hashing. So it will generate some hash value, which partition it should go for. Then it will go for some partitioning. See this partitioning automatically it is selecting P33, P34.
Yeah, hi Chandra. So for this hash partitioning, so you said the production ID, yeah. So to select this ID, it should have the, for example, it's not a primary key, yeah, something. So this is a something ID. Only few, it has a low cardinality things, yeah. for this one to select the partitioning.
Yeah, correct. See, based on the product ID, it will go and generate some hash value. Okay, so now no need to put only one ID here. You can put 2 to 3 IDs also. Okay, if you see this, I will explain. I will give you this particular document. Yeah. So this is what composite partitioning I will explain. Composite means you have to put 2 or 3 more partitioning in the particular queries. Okay. So this is create table employees number. You are putting that enable row movement, and you are making that this is range partitioning. Okay. Then list partitioning, list of values, while creating the table, create table name, column names, partitioning, partition P1. You are making some Chennai. Okay. So whoever is city equal to Chennai in the employee, then it will move to partition 1, partition 2, partition 3. Any other cities is coming with, it will go for the default partitioning. So that's, we may think that, okay, these 3 cities only, we are getting a lot of values. Then we are splitting the data into multiple partition, 4 partition. Hash partitioning, here we are selecting the hash algorithm on the employee number, partitions 5. So 5 partitions we are creating based on the employee number. Okay. So these many partitions will be created. So any column you can select, no issues. Even you can go for some 2 or 3 columns also you can select. So based on the values, it will select. But what is composite partitioning? Composite means combination of 2 data distribution methods. Okay. So one is you can go for this particular partition. So range and hash, range and list, range and range. So any partition, any 2 partition you can select in one particular query itself. Okay. So from the 10G only it is created, and I couldn't able to show you here. So actually to create this table. So why? Because we need to have enterprise edition
Yeah,
license.
I got that part. Also, okay, for other example, like, so if I have a like the millions of record for the person ID is the primary key, then can I able to choose that primary key, that is the person ID, as a hash partition key, because it will create a millions of partition. Yeah.
No. It will not go for millions. It knows where the range of values should go for. In that range only it will select. So you are selecting how many partition? 2 partitions only you are selecting, right? It will generate
Okay.
on hash
So,
value. So based on the hash
oh,
value, it will put.
so do you mean that if I choose the partition by 2, then it will only create 2 partition? They just
Yes.
make the half of this to make
Yes.
half table.
Yes,
Okay.
correct.
Okay.
If same
Okay.
product ID is coming, it will go to the same partition. If different product ID is coming, it will go for something different. Okay, something like odd number, even number. In
Oh
that way
yeah,
also
odd
it
even
will
number.
select. So,
Yeah, odd even
but
number.
it will generate hash value. System will generate a hash value. We are not going to generate hash value. Okay.
Yeah, that I know. Yeah. Okay.
But
So,
but we have to define that how many number of partition you want. Okay, I want to go for 10 partitions. Yes. See, employee ID you have 1 million employee ID you have. Okay. 10 partitions only you are creating. So each partition 1 lakh record it will go for. So it will automatically it will be partition. But we do not know which partition the data has been stored. So Oracle knows it where the data has been stored. That's what you have to do the collect stats. It knows it where the data is present.
so Chandra, another one question. So while I create for example, if I create a table, then if I mention the partition, then okay, that will optimize the performance. For example, if I have a legacy table, the history table, so because before I did not create any partition, but I have a table. So to improve the performance, to do the improve the performance tuning for that table, so we have an option to create again the partition for that table again, or we need to go for
Yes.
the other.
So we will normally call it as a rebuild of the table. Table
Oh.
rebuild. So you have to rebuild the table.
And one other thing, Chandra, sorry, I asked a lot.
Yeah, no
So
issues. Okay.
so for the performance tuning, so I got before one question. You can go by the table level or query level, because we can for most of the case we define it for the query level. Yeah. I think, yeah. So, okay, table level we can do it also. Yeah, maybe. What I had to try to say, so we need to do the performance. What are the difference between the performance tuning between table level and query level? I faced one question before.
Yeah, query level means whatever you are running the select query, right? So that select statement, you are doing some tuning. Okay, so what I told, instead of selecting all the columns, you are selecting only particular columns, right? Then you are doing that where class you are filtering the record. Then you are using some temp tables while selecting multiple table join. So 10 tables you are joining it. Don't go for 10 table join. You do 5 tables, first 5 tables, do it in one temporary table. Another 5 tables, do it in one temporary table. Then do the joins of these 2 temporary tables. One example I'm saying, but not 5 tables. You can go with 2 tables, 3 tables also. So you create the temporary tables, you join it, then you go for it. These are all the query level tuning, whatever I told here before. But this is table level. While storing the data itself, we are doing the performance tuning. Okay. So that's what table level. See, whatever here I have explained all query level. Okay, first one I have explained, right? So these are all the query level tuning.
Yes. Yeah, I got you. Yeah. Thank you.
You are selecting some large table, right? You are selecting some large table. So don't select like this, select star from the table name. Now, normally we should not select in the real-time project. Sometimes if you are selecting this entire table, table will get hanged. Your session also will get hanged. Normally in real-time project, you will not be allowed to use select star from the table name, right? So always you have to use some row number. If it is Oracle table, use some row number where row number less than or equal to some 5. So you will restrict the data. So if it is Teradata, some sample 5. So if it is some other tables, you will be using limit, right? So you'll be using limit statement to limit the records. Just limit 5 to limit it. Then you can see that how the data is being stored. And even you can put some where class here. Even sometimes you are going for some very big table. You are using created months. Okay, created at month. So I'm using created at month, something like that. It will be there. So 02 2023 or 03, something like that. Okay, so you are going to select some data in the 02 2003 in this particular partition range, but in that range also you are selecting only 5 records. So why? Because in this range also, this is month level, right? So entire month, how many transactions will be happen on the fact tables? We'll be having huge volume of data. So even if it is a Redshift and any databases, it will get hanged. So don't do that. You use limit 5, and even you can use where class also. You can put where class, where created at date. So even you will have. So one more. And so that's what you have to restrict the data. So created at date, you'll be having some date. Okay. So for an example, 12/02 2023. See why directly you should not use created at date. See, first it will go to this particular partition. Okay, this is top level partition. Inside that, it will go and select only one date. Then you are selecting only 5 records. So this will quickly give you the data. So this way you can improve the performance. Sorry, you can restrict the data in the select statement. This is what you have to do the select in the real time project. Okay, so always don't select star from the table name.
Yeah, I got it.
Yeah.
Thank you.
Yeah, thank you.
And what is parallel hint? Like we
Yeah, so
sometimes
you'll be
use
using
parallel.
some parallel here. Okay, some slash. The thing is here I cannot show you. That's one thing, and you'll be using something like some parallel 32. You are using this way. So this way you'll be running some queries. Okay, that means while running this query, it will execute this particular query. So the optimizer will give you some data parallelly. It will split up the range go and select the data, right? It will select parallel, some 12 threads is running in backend. It will allocate more resources to this particular queries parallelly, and then it will more thread is running. So that's what it will run very quickly. Parallel threads.
So 32 means it will create 32 threads.
Yeah, parallel processing.
So how will we know how much we can give, like 32 or 16?
No. Normally we will not give 32 and all, not for all the queries. Simply we have to select if the query is not performing well, then we will put like this. Then we will check, okay, whether the query is running or not. So that's the way you can do parallel 32 something. So you'll be using this way. See here. So select / parallel table name degree of parallelism. We are selecting 8 parallel degree of parallelism. Means here 8 different process with open to run the select statement fast. Got it? Here we are using select 8 parallelism. This way you have to use. Employee ID, it will select, say for an example, employee ID 100 to 200 you have. So in that it will select 8 parallel hints, 8 parallel processing. It will select. Clear? See, instead of 1, how many parallelism is running? 3 parallelism running, right? So this is what parallel enable hint / parallel index employee ID 8 they are using, where department ID equal to this one. So it will allocate this much parallel processing. Got it? So you can go for parallel 62, parallel 32, parallel 16, all this. Whatever you are seeing, anything in the select statement, the real-time project, right? In the real-time project, if you are going with anything in the query itself, they have mentioned / and // it is a parallelism, parallel hint they are using. Okay.
Okay.
So
And
don't think
also
that
in
this
hint
is like a commented out. So sometimes what we will assume that, okay, this has been commented out, right? So we will think that it has been commented out. This will not work. Not in that meaning. It is called parallel hint. Okay. Somebody used this way. That means they have used some parallel hint. Normally we will think, okay, this is nothing but something like that commented out. No, it is not commented out. It is using the parallel hint. 8 parallel processing. It will be running in the back end. It will select this particular table. So any other questions?
Chandra, yeah, one last question. So, for example, in the real time, so if I saw the tables, correct? So, if I just saw the table, then so how to check that how this table is doing like, for example, I need to do how to do the research, like instead for to check the performance tuning for the one table. So
Yeah, do the
need to
select,
do
do the explain plan.
explain plan.
Do the
Okay.
explain plan and then check whether this table has been partitioned or not. The explain plan only you have to do. Okay. So you can go for select star from the table name. What is the query you are going to use? So that's what you can perform. You can go for the performance tuning, right? You have to use always select explain plan only.
So, for example, everything the table first created in the dev environment, and then later once before put in the production environment, so they want to scan the table. Okay, what is the it is make some performance something like later or not. So those kind of thing need to be checked before put in the production. So for that one we need to.
That's why you have to put always partitioning. See, if it is big tables and all, you are going to use some fact tables, anything, just to create the tables with partitioning.
Okay, for
That
the
to go
fact
for
table always
fact
need to
table, we
put
are always go and check fact table. It will be a range partitioning. Definitely range partitioning will be there. So inside the range, one more composite partition will be there. If you go and check, two levels of partition should be there. Definitely. You can go and describe the table. Okay, and the describe table itself, it will show you the how many partitions are there. what is the partition column. If it is something like AWS Redshift and all, you can clearly in the below also, if you do the describing, it will show you that Teradata also, it will show you how this tables has been created. All this it will show you. So even if
Same
it is
thing for
Oracle, yeah, if it is Oracle, so how I explained, you have to put all underscore tab underscore partitions. It will give you that information.
the same thing for do for the dim table too. Yeah. So
Yeah,
both.
yes.
Okay.
And when you chose partition by employee ID, and if you don't give number of partitions, then it will create only one partition.
Which partitions, which type of partitions?
Like partition by
Mhm.
employee ID column name if we give.
Partition by which partition type? That's what we have to mention, right? Which partition? Partition by?
Maybe I don't remember. Like you said, column name. So column
No.
name.
Column name is partition key. Which partition type we have to go for? 3 partitions are there, right? See, always we have to mention partition by range, partition by list, partition by hash, right? You have to mention that way. So you want to go for
Okay.
hash partitions?
Okay, hash partitions means we have to provide number of partitions. No need, right?
We have to provide number of partitions. See, partition by the type of partition. Which type of partition we want to go for? Then inside we have to mention the partition key. Then how many number of partition we have to go for. So for an example, here we are creating 5 partitions. You assume that 5 partitions means based on the employee ID. So it will create. Okay. So you are going for employee ID from 100 to 1000 or yes, 100 to 2000. There are some 100 values are there in between. Okay. 100 values are there. How many partitions you are creating? 5 partitions. So that means 100 to 110 or 100 to 120 it will go for one partition. See, I'm saying up to my knowledge, I'm dividing that particular employee ID with 100 to 120. But Oracle knows it based on the hash value. So hash of employee ID, it will make one value. Some unique number will get generated, hash value. With that hash value, it will put it in the partition. Okay. These hash values will go to one particular partition. This hash value will go to one particular partition. This hash value should go to another partition. In that way, it will create.
So it will take the beginning value and end value, and then it make hash value and divides into 5 partitions.
Right, correct. It will split the partition into 5. Then it will generate hash value. Oracle knows it. Where should I go and place this particular value?